Ryan sees me though in ag. He sees my multiple personalities.
Alright, here we go. We've got an activity planned for us today.
Okay. Are you going to sing with the microphone?
I forgot about the microphone. I'll bring that tomorrow.
Please sing. That's why you sing to the talent show.
Yes. Hey, I'm doing the talent show. Well, hopefully I can make auditions.
I might make a swag appearance.
Hold on.
Yes.
It's passing C.
Roshan,
If a large majority of us pass the test.
pass the test. What test? The AP test?
Oh, no.
Oh,
He's like, yeah.
But
But this group, I'm sorry, I don't, yeah. Sorry, guys.
Alright, here we go.
Hey, post on your YouTube.
Text
It's all
us.
bad.
Coach
It's better in person. I have to be able to feed off of you.
Oh my God.
Live stream it.
It's not the same.
Can we get Derek in here? It's fun when you and Derek sing together. We could go on a picnic.
You know how you sing for the girls right before they go to state? Right before we take the AP test, you should sing for us.
That's a good idea. Right there.
Like this. Good job, I'm making big moves. Like it.
Alright, we're doing 3 things today. We are finding the average value, which is actually something we've been doing already. We're just looking at it with a different name here. And then we're looking at the MVT for integrals. We've previously done the MVT for derivatives. And then we're going to look at the second fundamental theorem of calculus, which is one of the easiest things we do, but you guys usually find a way to make that difficult.
Yeah.
So, please don't make that difficult. That's super easy. Alright. So what we're going to do here is we're going to find the average value of this function over this interval, and then we're going to do an activity with this big graph that we have to kind of see what it is the average value actually represents. Alright. So what's the key word we see here when we're finding the average value of the function over the interval? Average is the key word. What does that tell me I need?
The average.
Oh, those are disappointing me.
What are we doing? What?
Right here. When I see the word average, okay, average velocity, average acceleration, average temperature.
You need a ratio or something, a fraction.
I need a fraction. I need the, as Leilani says, I need the change in the function above over my change in the interval. Okay? So how do we get to the change in the function above?
Yeah.
We have to integrate. Alright, so we have to integrate. We're going from -1 to 2, 4x cubed minus 3x squared dx, and I need to divide by 2 minus -1, which is 3. How else have you seen that 3 instead of on the bottom?
1/3.
1/3. Okay. Alright, so we're ready to excuse me. Integrate. Alright, so if I integrate 4x cubed, I get x to the 4th, integrate 3x squared, x cubed. We're going from -1 to 2. Abby M, which one of those two do we plug in first? The top one. So that's going to be 16 minus 8. And then plug in the -1, so that's going to be 1 minus the -1. Alright, so 16 minus 8 is 8. The 1 minus the -1 is going to give me 2. It's going to turn into a -2. So that means we're looking at 1/3 times 6, which means I get 2. Okay, what does 2 represent? That is the average value. Okay, now what did I call it? Activity. The activity we're going to do is going to help us figure out what that average value is. And I'm hoping your desks are not too slanted and this will work.
Yeah.
Do not eat the candy until we're finished with the activity.
Can we clean our desk? Like, is the candy going to touch our desk?
It's going to stay on your paper.
Okay, good. Okay, well, I'm just saying, there's some nasty people that be touching desk and a lot of germs spread that way, and that's just gross. And it's flu season.
It's supposed to stay on your
I'm not trying to get sick.
That should stay on your paper. I think I got enough M&Ms.
That was Jennifer's joke, guys. So loud.
Oh, hi. I didn't hear your joke. It was making fun of you, Mallory.
Why is everyone just like making fun of me today? Why is today just like not a good day for me?
It'd be like that.
I like how they're mean. Did you already eat?
No.
I know. I feel like I'm gonna be like.
It's not counting them, so.
I'm just trying to go home and be done with it.
On a scale of 1 to 10, if I was to apply to the world record for the world's strongest neck, you think I'd win?
No.
I'm a song
That's not a good record.
Hey.
Boys that do the face
I was supposed to say.
Way too many M&Ms.
I can help you.
There were
Like,
what that?
What, I would eat?
what? Undenied or unreplied. Oh. Yeah. Yeah. Girl.
Please replied to me.
Oh,
What? Why was it so small?
no, that's
This one is completely round.
Oh, make that noise.
Why? Why? I'm not going to ask questions.
I love
Hey, you're not allowed to eat the activity till we're done.
Hey, good luck.
I remember doing like this in like 3rd grade.
What's your favorite candy? Sour Patch Kids?
Wow, she made hers look so like nice.
Alright.
Sour Patch Kids, huh? That's your favorite candy.
Here's what you're getting ready to do. You're going to take these M&Ms and you're going to fill up the space that's trapped between the function and the x-axis. So over here on the left side, you know, our interval was from -1 to 2. So -1 is over here on the left, 2 is over here on the right. So on the left side, your M&Ms need to be below the x-axis. Over here on the right side, your M&Ms need to be above the x-axis. So I want you to fill up that space with your M&Ms. Go.
I'm making a rainbow right now.
Does not have to be exact, just get it close.
That's why.
Just do what you're supposed to do. Just one day. One day.
What? I do it every day. All the time.
What's that one?
I don't know what you're talking about.
It's Eminem and
So-
like a voice.
so-
I'm going.
He says, I'm Eminem when Eminem and
They're all rolling.
Did someone just drop one?
Now the ones,
I'll eat it.
if you have M&Ms left over after you fill up your 2 area spaces, you can eat the ones that are left over. But the ones that are in the space, they need to stay there.
I want to make it pretty, like a rainbow.
Dang it, I think they're gonna fit in exactly in my
I feel so lonely back there.
You shouldn't feel so dependent on people. You should be able to be your own person, Zach.
Good job. Good job.
wise words from Mallory just said, everyone thinks so mean to me. I don't want to be here. You literally just
We're being mean to me.
Where is that?
Well, that's mine, bro. Oh, there's your name. Except for Coach White, he was part time too.
Oh, I thought you didn't have any left over. I don't have any left over. I didn't have any
Look,
left
I'm
over.
making a rainbow.
Anybody short some?
Very happy. Yeah.
I'm not sure yet.
Just like swiping in my hand.
Oh man, you really think you're that?
They're all sliding. They're staying in place.
Elijah, you good?
I prefer the peanut
Yes.
I didn't smell or did you guys?
Alright, here's your next step.
Supposed to do these like
Now you're going to take all of these M&Ms and they're all going to go above the x-axis and you're going to form a rectangle from -1 to 2. So all the M&Ms need to be above the x-axis and form a rectangle from left to right.
Wait, what?
All the M&Ms need to be above the x-axis and from left to right you need to form a rectangle with your M&Ms.
Like from the very left.
From left to right.
Does it matter how tall they are?
I mean, it's not. You're not going to have a choice. It's going to be a certain. It's going to be a certain height. There's no choice to it. You can't decide how tall it is. You got to make a rectangle with what you have.
You just make a rectangle.
From 0 to what, 2? No.
-1 to 2. The left side of the graph to the right side of the graph, and get them in there as tight as you can. And you got to realize the point I'm going to make isn't going to be exact since we're dealing with M&Ms, but it's going to be close.
I really want to find that M&M video. That was really funny. How did? Oh, that's what you're doing. You should have done
No,
it.
they have
Or
to
we
be tight.
have to move it with a straw.
They have to be tight. There can be no space. There can be no
Oh my
space.
God. Okay, okay.
You hear me? Everything needs to be pushed out.
Yeah.
It's so precarious, bro.
Hurry.
It's stressful life. So we're not M&M architects.
Moving M&Ms.
I need like okay.
Yeah, well, they move after I move them.
How was that the point?
I know you laughed at that one. Spread out a little bit so you can sleep in there.
There we go.
Hey, it's not moving.
That's how hot it's supposed to be.
No, it's supposed to go to 2.
Well, there's no number right here, so I can't really tell what's two.
what I've asked you to do. That's what I was trying to do. I thought.
I'm not gonna have enough M&M in this. That's true.
I thought I was doing what I was supposed to do.
I need to watch just to scoot a little bit. Like a little bit on from the off. You said this hurts my OCD. It's not real. Stop. Stay right. This is really bad.
You should have done Skittles. I like Skittles.
Yeah, but Skittles are bigger. I want the smaller.
Yeah.
So what do I do with these extra ones?
Eat 'em.
No.
Ew.
Alright. Take all that out.
Imagine and they're like eating the food and it's like I hate that. And they're just like, and people
I could be one of those all the time. Like every time I eat food, I'm like,
ew.
Alright, we should all be pretty close. Is there anything that you guys noticed? Now that you've formed your rectangle. Anything about your rectangle that you noticed? Related to what we just found.
It's too high.
It's too high.
Oh, and our average was 2.
And your average was 2.
Look at me being smart.
Everybody noticed that? If you did a pretty good job filling it up, now again it's not going to be exact since we're using M&Ms, but what you're going to notice is when you fill it up, okay, you should have been able to fill it up and then made a rectangle that was too high. And if it wasn't exactly 2, it should have been somewhere close to 2. Okay? So what does that mean 2 represents?
The average height.
Average value.
All right, and let's go back to the word average value. When I say average value, what type of value do you think we're talking about? We're talking about a Y value. Notice we're talking about, am I at 3 or 2? I went too high.
Yeah, I was looking at the same thing.
Okay, so we're talking about that Y value right there. So when I ask you to find an average average value, I'm looking for the average Y value. So what that means is if I take all of these Y values that are right here, between -1 and 2, the average Y value is going to be 2. Okay, so the average Y value is going to be 2, which is located right there. All right. So what this problem does is we had 1/3. We had the integral from -1 to 2 of, was it 4x cubed minus 3x squared dx? All right, now somebody raise your hand and tell me, what do we find when we find that piece? What is it we find when we evaluate this? It represents 2 things. Abby?
The area under the curve.
Area under the curve, and what is the other thing it represents? The change in the function above. So this right here is the area under the curve. So that represents all of this blue area. Okay? So how much area did we have on this problem? We did not have 2. We had 6. We had 6. And then when we multiplied by the 1/3, that's where I ended up with the 2. Okay? So what this 2 is, it is the Y value, but it's also the value, or it also tells me the height of the rectangle that is formed that has that exact same height. Does that make sense? So I had this area and this area, and then we formed it into a rectangle, and then the height of that rectangle was 2. So the average value is also the height of a rectangle that is formed that has that exact same area. Okay, those are the 2 things that we find when we're doing this.
How did you form a rectangle? I do the M&Ms, but like, how did you form it up there?
You move this up, and you move this down, and then it forms a rectangle. Just like you move your M&Ms up, and you move your M&Ms down, and then you distribute it, it formed a rectangle.
So the whole area, the whole blue area is 6.
The whole blue area is 6. The whole red area is 6. Because how wide is this rectangle?
1 to 2.
How wide is that? 3. How tall did we say it needed to be? 2. What's 3 times 2? 6.
Oh, so 2 is the...
2 is the height of the rectangle, and it's also the average Y value. Is what it is. Okay? So we did this to show that this area, we did this activity to show that the area that's here and the area that's there, if I combine it, that produces a rectangle with the same area, and then the height of that rectangle is the average value. Okay? And that's why we did that little thing. All right. So go ahead and eat your M&Ms and flip the page over, and let's move to the next problem.
Oh, no,
Now we're getting into the MVT for integrals. Somebody raise your hand and tell me what was going on with the MVT for derivatives. Done right?
A-rock equals I-rock.
A-rock equals I-rock. Okay, and what do we use the MVT for derivatives to prove? That an I-rock exists. Same concept though, right? Okay, so we use the MVT for derivatives to prove that an I-rock exists. So now we want to figure out what is it that we want to use MVT for integrals to prove. Excuse me. So, what do we notice that right there is?
Fraction.
Average value.
This right here is the average value. That's what we just did. Okay, and we got more specific and said instead of just average value, it represents the average Y value. Okay, that is the average Y value. Okay, So what does f of c equal? What does it represent?
A point on your function. Okay. Your y value on a function.
There we go. This right here represents a y value. Is what it is. That left side represents a y value. So back on MVT for derivatives, we use the MVT for derivatives to prove that what exists? An IROC exists. Okay? And that IROC was equal to what? An AROC. So what does it look like we're going to use MVT for integrals to prove? That a y value exists that's equal to the average y value. Okay? So that's what's going on with the MVT for integrals. We're going to prove that a y value exists that is equal to the average y value. Okay? So if I scroll back up here, okay, we said the average y value was what? 2. Okay? So that happened right there. Okay? And where does this y value exist? On my interval. Okay? Just like MVT for derivatives, we're proving that an IROC exists on this interval. Here, I'm proving that a y value equals the average y value, and it has to exist on that interval. Right here, it exists at that value right there.
So your average y value was 2.
My average y value was 2. Here is a y value of 2.
So that's saying the y value has to equal your average y value.
There has to be a y value that equals the average y
So
value.
instead of the average y value of 3,
Then there would have to be a y value that's 3.
but since your interval was negative 1 to 2, it wouldn't work.
No, you're confusing x values and y values. The interval is x values.
Okay.
The y value is obviously y
So how do we
values.
know that? So we have to look at the line to determine if there's a y value of 2.
You're confusing me.
How do you know that there is an average y value at 2?
How do you find that?
Like, how do you know that the y value equals your average y value?
Because that's what the theorem says.
So once you find your average y value, there has to
be a y value that is that value. That's what this theorem is used for. So if I have an average value that's 1/2, I know that on this interval there has to be a y value that's 1/2, at least one.
So there's no other way to view it. It just has to work.
Has to work.
Can there be more than one?
There can be more than one. Just like on the MVT, there can be more than one. This just guarantees that there has to be one. Okay? So, let's look at our first example. F of x equals 9 over x cubed from 1 to 3. Okay? I want to find the average y value. Once I find that average y value, then I'm guaranteed that there is a y value that is equal to that, and then I want to find the x value where that happens. Okay? That's what we want to do. So what do I do to get started to find the average value? Integrate. From 1 to 3, 9 over x cubed dx, and then what needs to be up front? 1 over b minus a, so in this case, 1 over 2. Alright, so we think about, excuse me. Think about that as 9x to the negative 3, so the derivative of that's going to be what? 9 over negative 2x squared from 1 to 3. Alright, now notice I only have one term. What do we like to do when we only have one term? Well, I recommend you do anytime you have one term. Take something out. Good, Haley. So I'm going to take that out, and I'm going to take that out. So that's 9 over negative 4. That only leaves me with 1 over x squared inside. Very good. Makes it much easier to work out. Abby, which one do I plug in first? The top one. So 1 over 9 minus 1 over 1. So that gives me negative 9/4 equals negative 8/9, or times negative 8/9, not equals. I don't know where. Everybody agree with that? Yeah. And that gives me, we just happen to get 2 again. Not on purpose. All right, so raise your hand. Somebody tell me what this 2 represents.
Is that average y value?
Raise your hand. All right.
Average y value.
Okay, what else is it?
It tells you there's a y value there.
There has to be a y value that's equal to 2. What else does 2? What else can I know that 2 is?
The area of the rectangle.
Close, not the area.
The height.
The height of the rectangle. Okay, and how wide is that rectangle? 2. Okay, it's 2 wide. Okay, and this tells me my rectangle is 2 tall. So, and that gives me the area that this is right here.
Does that mean your area is 4 then?
That means my area is 4.
Oh.
All right, now we want to figure out where that y value is. So I know I've got a y value. I want to know what x value does this y value occur at. So what do we do next, John Ron?
You just plug this in.
I don't. Well, I do, but not the way you're thinking, if I'm reading your mind. Roshan? You said it equal to 2. You said it equal to 2. Because remember, what does this 2 represent? A y value, so I'm not going to plug a y value in for an x. All right. So I'm going to switch the spots here, make it x cubed equals 9 over 2, and then take the cube root. And I get x equals the cube root of 9 halves. Now somebody else that hasn't spoke up today, tell me what's going on at x equals the cube root of 9 halves. Raise your hand, please. You two, you guys have talked. Elias, what's going on at this spot? Jennifer?
Is that where your y value is?
That's where my y value is. So at the x value of the cube root of 9 halves, I have a y value that's equal to 2. Okay, which is the average y value. That's what's going on there. Next one. I think I'm getting too close. I'm getting too close to that, and it thinks. All right. Next one. G of x equals x minus 2 times the square root of x from 0 to 4. So I'm integrating from 0 to 4. What's going to be out front? 1/4 x minus 2 square root of x on the inside. Integrate. So 1/2 x squared minus, what does that one give me? So it becomes 3/2. I need to multiply by 2/3, so that makes it
2/3 x.
gives me 4/3. Plug in the 4. Now, why can I not take something out this time? There's more than one term. So plug in 4. 4 squared is 16 divided by 2 is 8. 4 to the 3/2. What does 3/2 want to do to 4? Square root it and then cube it. So the square root of 4 is 2, and 2 cubed is 8, and 8 times 4. And then when I plug in 0, what's going to happen? I get 0. All right. 3 times 8 is 24. So that gives me negative 8 over 3 when I put those two together, which gives me negative 2/3. Abby Davis, what does negative 2/3 represent? Average y value. Okay, and the MVT for integrals, Advait guarantees what?
It guarantees that there is a y value that matches the average y value
On
the interval 1 and 3.
the interval 0 to 4. 0 to 4. Very good. Okay, now we want to find the x value where that occurs. Okay, Courtney, what do I do to find that x value where it occurs?
Plug in.
Plug it in for what?
Y.
Very good. What?
Since that y value is negative, still in the interval, interval 0 to 4.
Now remember, what did you just say this was?
The y value.
What does this represent?
Oh, the x values.
Mm-hmm.
Oh, so then if like your x value is negative or something, then it wouldn't be on the interval.
Yes.
Okay.
All right. Hopefully somebody has their calculator because we're going to use our calculator to finish this up.
I got mine.
I have 0 equals x minus 2 square root x plus 2/3. How can I use my calculator to solve that? I would use the quadratic formula.
Do you know?
Graph it and
Or you can search for
all right, I like graph it. Graph it and look for what?
X-axis.
What?
Where hits the x-axis?
Where it hits the x-axis. I'm looking for a 0. So let's graph it and find the 0. So x minus 2 square root x plus 2/3. Gives me that. And I'm only concerned with the where it touches the x-axis where? Between 0 and 4. It looks like it does it twice. How do I get to the 0? Nope. Menu, analyze graph, 0. Click on the left, click on the right.
What do you mean?
I mean, you got to take that arrow to the left side of where it touches and hit enter. Take the arrow to the right side and then hit enter. And then it'll give you your 0. Anybody have one yet? Say it again. 0.179. Anybody get the other one? Should be 2.488 is the other one. All right, so Maddie, what's happening at those 2 points? Very good. So this is the 2 locations where the y value equals negative 2/3, and negative 2/3 represents what? The average y value. Very good. Let's see how we're doing on time. No, we need to move on. All right, we're going to go to the second FTC. Second FTC, what's going on up there?
You've got a derivative.
Taking a derivative of an integral. So they cancel out. The derivative of an integral is going to cancel each other out. Everybody agree with that? Because the derivative takes me down and the integral takes me back up. Okay? So this right here is equal to, whoops, is equal to f of x.
Why wouldn't it be FT?
Because of that right there. Whatever that variable is right there, that's what you need to plug in. Okay? Now sometimes there could be something up there other than just x. Whoops, too many parentheses. Sometimes there's something up here just other than x. If that's the case, I do the same thing. I plug that in, but I have to do one more thing. What do you think that one more thing is? Take the derivative of it. So if there's something up here other than x, you plug it in, and then you have to multiply by the derivative of whatever it is you're plugging in. Okay?
Do you not do anything with the bottom?
I don't. And then the only other small change is that the variable could be in the bottom. If the variable's in the bottom, I'm still going to plug that variable in. I'm still going to multiply by the derivative, but what do you think else needs to happen?
Negative.
I need a negative. Why do you think I need a negative?
Because of those rules.
Because of those rules. When I switch it, I gotta have a negative. So I could switch this, and that's where the negative comes from. That's all there is for the second FTC.
So do you
Plug it in, multiply by what you're plugging in.
You don't multiply them together? Or do you like that?
Leave it like that. Alright, so derivative of an integral, you should be thinking that's the second FTC. All I have to do is plug in. So if I plug in, there it is. Super easy. You agree? But some of you are still going to screw it up.
Probably.
Okay, on the next one. Plug it in. But the x came from the from the bottom, so I need a negative. Make sure the negative goes to the whole thing.
Did you write like -3 minus cosine?
You could do -3 minus cosine x. That'd be fine. Alright, and my last one. Plug it in. So square root of sine of x, and then I have to multiply by cosine of x. There it is. Now, what some of you are going to do is you're going to see this, and then you're going to go, all right, I need to integrate that, and I need to plug in sine, I need to plug in 0, and then I'm going to take that answer, and then I'm going to take the derivative. If you do that, this is what you will get. Okay? If you go through that long process, you'll end up with the same answer, but obviously too much work.
Why is it not? Why did it use cosine? Why is it not like a 2 if you sine square root?
All I'm taking the derivative of is this. I ignore this. All I care about is what is it I'm plugging in. That's what I take the
Like,
derivative
why don't you take the derivative of here?
of. What?
I guess because then it'd be 1. Never mind.
So, but when I do a quiz or when I do a test, I'm going to try to make it to where I have something in here that you can't integrate, which is going to force you to use the second fundamental theorem of calculus. I don't know why you wouldn't want to use it anyway. Okay, plug it in, multiply by the derivative of what you're plugging in. Second fundamental theorem of calculus. Yes.
2 is wider than 1 part of the derivative of x would be 1. There's nothing to say.
Which one?
On t plus 1.
This one? It's what you're plugging in, not the result. You only multiply by the derivative of what you're plugging in.
Technically you are, but the derivative of x is just 1, so it's just not there.
Correct. Okay, so we started out with finding average value. How do you find average value? Integrate over the interval. Integrate over the interval gives you the average y value. Okay. MVT for integrals. Raise your hand if you can tell me what the MVT for integrals represents or guarantees. Roshan?
It guarantees a y value. It guarantees that there is a y value equal to the average one.
On the interval. Very good. Guarantees that there is a y value equal to the average y value on the given interval. Okay. Second fundamental theorem of calculus. 2 steps. Step 1, plug in your variable. Step 2, multiply by the derivative. And if your variable's in the bottom, you also need a negative. There it is.